All right, today we're going to be covering 2.7 and 2.8, transitive properties and vertical angles. So let's go ahead and get started. So we're going to go ahead and begin by factoring. So we have x squared plus 2x minus 15 equals 0. Please feel free to go ahead and pause the video if you'd like and try this one out on your own first. So looking at this is already in standard form, ax squared plus bx plus c equals 0. So the first thing I'm going to do is I'm going to take my a value, which is 1. I'm going to multiply it by my c value, which is negative 15. And that answer will give me negative 15. So from here, I want to find numbers that add to be 2, that middle term, multiply to be negative 15. So all the numbers that multiply to be negative 15, let's list those out. We have 1 and negative 15, 3 and negative 5, negative 1 and positive 15, and negative 3 and positive 5. Out of all these choices, which one will add to be positive 2? Well, that would be these last two here, negative 3 and positive 5. So at this point, I draw my double bubble, and we know it's set equal to 0. So I can put equals 0. Now the first thing I put in each of these bubbles is the variable that we're working with. And in this case, we're working with the variable x. So I'll just go ahead and place an x in both bubbles. And then the second thing that goes in my bubbles is the terms that we just found that multiply to be negative 15 and added to be positive 2. So that'd be negative 3, positive 5. So we're left with x minus 3 times x plus 5 equals 0. Now I can take this first part and set it equal to 0, so I can make two equations, x minus 3 equals 0, and we also have x plus 5 equals 0. So at this point, I have two equations and I can solve for each of them. So this will give us x equals 3, and we also have x equals negative 5. So those are our two answers, x equals 3 and x equals negative 5. All right, here it is once again, so you guys can go ahead and check your work just by looking through, but it's the same exact thing. Next up, we have this problem. Go ahead and pause the video if you'd like and try this one out on your own, and then we'll work through it together. So, looking at this one, we're going to do the same exact steps. I take my a value, which is 1, multiply it by my c value, which is negative 42. So, multiplying those will give me negative 42. So I want to find numbers that add to be 1 and multiply to be negative 42. So listing these out, we have 1 and negative 42, 2 and negative 21, 6 and negative 7. We have negative 1 and positive 42, negative 2 and positive 21, negative 6 and positive 7. Out of all of these, which ones will add to be positive 1? Because again, there's a missing 1 right here. Well, that would be positive 7 and negative 6. So I create my double bubble, set it equal to 0, and I put the variable that we're working with in first. The thing that comes in second in both bubbles is the terms that we just found. So that'd be a negative 6 and a positive 7. From here we can set up two equations. So we have x minus 6 equals 0. And we also have x plus 7 equals 0. Solving for each of these, we get x equals negative 7 as one of our answers. And as our other answer, we get x equals 6. So we have now factored both of these. So again, we want to practice our factoring. We want to get better at these, so you'll continue to see these as we continue on. So with that being said, let's go ahead and jump into the transitive property. And again, here's the answer. If you guys would like to check through, you can go ahead and follow the work pretty clearly. So the transitive property, this is a very important property. We've already touched on this once before. So suppose that angle A is congruent to angle B. So let me go ahead and draw that real quick. A is congruent to angle B, and A is congruent to angle C as well. Is B congruent to angle C? Well, yes. This is the transitive property. A is equal to B, B is equal to C, then I can skip B entirely and say A is equal to C. Same thing works for B and C as well. So if I know A is equal to B, A is equal to C, I can skip A entirely and go straight from B to C. So the transitive property is just skipping the middle step. It's like taking the bus. I can take the route from A to B and then get off at stop B. Then I can get back on at stop B and travel all the way to C. Or I can just get on the bus at stop A and ride it all the way to stop C. So again, that's all the transitive property is saying. It's just skipping that middle step here. So we have a theorem for the transitive property, and this is what it is. Sorry, I forgot to mention. The transitive property of algebra can be used to prove this general rule. So again, this is an algebra rule that we're carrying over and using in geometry, and it still works because we're still dealing with some algebra in this. So the transitive property theorem is if angles or segments are congruent to the same angle or segment, then they are congruent to each other. Meaning if angle A is congruent to angle B, and angle B is congruent to angle C, I can say that A is congruent to C. That's all it's saying. If angles or segments are congruent to congruent angles or segments, they are congruent to each other. All right, so let's go ahead and try out the transitive property, see if we understand what's actually happening here. So if A is congruent to B, find the measure of angle A. So we already know that they're congruent. And I don't know why this plus sign's here. It doesn't need to be here. It just got dragged in. So they're congruent to each other, which means that I can set them equal to each other. So I have x plus 10 equals 2x minus 4. If I solve for x, I get 14 equals x. So that's what x is equal to. But we want to find the measure of angle A. So I can plug 14 back in for either equation because they're congruent, and I'll get the same answer. If I plug it in for angle A, though, I get the measure of angle A equals 14 plus 10, which will give us 24 degrees. So again, find out that x is 14, we plug it back in, and we get measure of angle A equals 24 degrees. And that's our answer. Next up, if angle 1 is complementary to angle 2, which means that they add to be 90 degrees, and angle 2 is congruent to angle 3, so these two angles are congruent, then angle 1 is complementary to angle 3 by what? Well, all I'm doing is I'm taking angle 3 and I'm replacing it with angle 2. So I'm replacing angle 2 with angle 3. What's another math term for that? Oh yeah, substitution. So we're just substituting in angle 3 for angle 2. This will give us angle 1 plus angle 3 equals 90 degrees, which shows that they are complementary. So substitution works perfectly fine. All right, the last thing that we have for the transitive property is a proof. And this proof is pretty straightforward. It's just dealing with what we just saw. So let's go ahead and work this one out. Number 1, my first statement, angle 1 plus angle 2 equals 90 degrees. That's given. We also know angle 1 is congruent to angle 3. That's also given. Let me go ahead and draw that. Angle 1 and angle 3 are also congruent. We know that angle 1 plus angle 2, that creates a 90 degree angle. We want to prove angle 3 plus angle 2 equals 90 degrees. Well, we can do that right now. We can say angle 3 plus angle 2 equals 90 degrees. Well, what did I do? I took angle 3 and I substituted it in for angle 1. So this is our substitution property of equality. And I'm just going to write substitution property. You don't need to include the of equality every time, but this is just fine as is. So we now have proven that angle 2 plus angle 3, those are also complementary angles, which is exactly what we were trying to prove in this. All right, let's go ahead and move on to vertical angles. And we've talked very briefly about vertical angles already. So vertical angles are created anytime that there's an intersection, and we'll see quite a few of these. So, first off, some definitions. Our first definition is of opposite rays. Opposite rays are two collinear rays that have a common endpoint and extend in different directions. Those are what opposite rays are. So, if we look down here, I have ray AB in blue, and I have ray AC in red. AB and AC are opposite rays because they share a common endpoint of A and they're going in different directions. Oftentimes, lines can be considered opposite rays if they have 3 points on them. You can choose any of those points to create opposite rays out of. So keep that in mind. Opposite rays are often created when you see lines, and they're often going to be shown with those. So, vertical angles. This is a very important definition, and that will help us out a lot when we're dealing with these angles. Vertical angles are two angles if the rays forming the sides of one and the rays forming the sides of the other are opposite rays. Now, an easy way to remember this. Vertical rays are created whenever an X is created with angles. Vertical rays are just on opposite sides. So angle 1 and angle 2 are vertical angles. And vertical angles are always congruent, no matter what. So angle 1 and angle 2 are congruent. Angle 3 and angle 4 are also congruent. So that's how you can determine if you have vertical angles. Anytime that you see two lines intersect, vertical angles are formed. So let's go ahead and prove one of these. So given angle 2 is congruent to angle 3, prove angle 1 is congruent to angle 3. So first off, let's go ahead and write our given statement. Angle 2 is congruent to angle 3. That's given. So angle 2 and angle 3 are congruent to each other. Now, looking at this, angle 1 and angle 2, what's their relationship? Well, they're vertical angles. So my next statement, I can say angle 2 is congruent to angle 1 because vertical angles are congruent. And if that's the case, well, if 2 is congruent to 3 and 2 is congruent to 1, could I skip 2 entirely and say angle 1 is congruent to angle 3? Absolutely. So I can say angle 1 is congruent to angle 3, which is what we're trying to prove up here. The reason I can do that is the transitive property, what we were talking about earlier in today's lesson. So the transitive property allows me to skip over angle 2 and go straight from 1 to 3. Now looking at this, we can also see angle 1 and angle 3 are corresponding angles as well. So that would make sense that these lines are parallel, if those two angles were congruent, which they were, which we'll talk about more in a couple days. All right, so next we have our final problem of the day. Given the measure of angle 4 equals 2x plus 5, measure of angle 5 equals x plus 30, find the measure of angle 4. So go ahead and pause the video if you'd like and try this one out, and then you can check your answer right after. So looking at this, angle 4 and angle 5, their relationship is that they are vertical angles, meaning that they are congruent to each other. So we can say the measure of angle 4 is equal to the measure of angle 5, which allows us to also say 2x plus 5 equals x plus 30. So from here we can go ahead and solve for x. Subtracting x from both sides, I get x plus 5 equals 30. Then subtracting 5 from both sides, we get x equals 25. From here, we're going to go ahead and plug that back in, and I can plug it in for angle 4 or angle 5 because they're congruent. Doesn't matter which one you plug it into. If I plug it into angle 4, we have the measure of angle 4 equals 2 times x, which is 25, plus 5. Well, that'll give me 50 plus 5, which is equal to 55 degrees. So the measure of angle 4 is equal to 55 degrees. All right, that is it for today's video. Again, there is going to be homework that's posted, but you guys do not need to do that tonight, just because this is an asynchronous Wednesday. Normal years, you guys would. This year, not needed. So go ahead and work on this tonight. Thank you guys so much for watching. If you guys have any questions, please let me know. If it is the asynchronous day for you guys, no homework tonight. Enjoy the rest of your night, and I'll see you guys tomorrow. Take care.